Sup guys, yo, how's it going everyone? Just getting my stuff set up here. Oh, that does not look pretty, does it? Is it just me, or is that removing? Oh, what the heck? I'm dropping frames like a boss. Is it just me, or does that look very, very blurry and juddery to you? Doesn't look very smooth on my screen, choppy. Alright, let me play with some settings real quick. Let's have a look. Alright, let's try changing that setting. Okay, that still looks choppy. That's not looking so good. Okay, let's change another setting. Okay. It goes choppy when there's like heavy movement, and then it sort of cleans up a bit. What's going on here then? I don't think I've really changed anything. Ah, I enabled look ahead. Maybe that's what it is. Maybe I shouldn't enable look ahead. No, still terrible. What's going on? No, so the internet connection is not an issue. You see this green box down here on OBS. You got this little green box at the bottom. That's a combination of the connection speed to the internet and also the CPU, how bottlenecked the CPU is. I think that this is GPU, because let's open up Task Manager real quick. Right, okay, so we're smooth at the moment. I've got Task Manager open with this here. Right, so if I do a bunch of stuff like this to make it go choppy, what happens to, so on Task Manager now, the graph, doesn't really look like we have a big spike. No big CPU spike, no big graphics card spike, although video encode is like literally topped out. Okay, let's try going back to this low latency. The stream has been fine for years. I'm not sure if YouTube has changed something. That's still really bad. Oh, that's better. Okay. I just very quickly, I've been changing some settings, but I just stopped and restarted the stream. And it seems like you need to stop and restart the stream in order for the settings to apply. So that's now not going choppy anymore, is it? That looks okay. What does the stream look like for you guys, especially with fast movement? What does fast movement look like? Does it look like really blocky, or does it look okay? Because I want to make sure it looks all right for you guys. So like moving the camera around the screen here, does it look all right? Or is it kind of really blocky? Fast movement seems a bit blurry. Okay, cool. Most people are saying it looks great, so we're not going to be doing any crazy moving around like that when we're repairing the amps. So, Ari says the video quality is poor. Well, Ari, you seem to be the only one that's saying it's very poor. So, Ari, I would check your settings. Make sure that you're watching this in 1080, 60 frames a second. For most people, it seems good. So, Ari, I would check your video settings, my friend. Alright, cool. How's it going, guys? How is everyone doing? Good morning to you. I got the worst night's sleep last night. So hopefully we don't have any issues today with really complicated stuff that's going to fry my brain. Can you fix sound digital lamps? Yes, Sound Digital are one of the brands that I specialize on. I'm really quite well experienced with Brazilian modern circuit designs. So yeah. What happened to Clarion? I have no idea. Clarion were a little bit before my time, not gonna lie. Like, I was a teenager when Clarion were kind of killing it, and I didn't have a car, so didn't really buy stereo stuff then. Sup, Dr. Diner? Yo, yo, yo. It's got clip light on and no sound. That is an output section failure, my friend. That the clip light with no sound means that the output section isn't oscillating. It means that there's no class D switching. It can also mean that there's no rail voltage build. But yeah, basically clip and power light is bad news, means there's an output section failure. $850, if you've got static through your system, even with the RCAs removed, then yeah, the channel needs repairing of the amplifier. Justin says, hi, video quality isn't the greatest. Looks like 360p. I'm on 1080. What is going on with the quality at the moment from YouTube? I am streaming at 6000 kbps, which is what I've always streamed at, or actually higher than what I used to stream at. I am streaming at 60 frames a second. I wonder whether that's it. Guys, I'm going to change it from 60 to 30 frames a second, okay? And tell me if it suddenly looks a lot better. If I go to video settings, where is it? Here we go, video. Right, I'm going to pause the stream for 1 second, so the video will freeze for just a moment. But 5 seconds later, it should start back up again. So I'll see you guys in 1 sec. Don't go anywhere. I'm just going to pause the stream for 1 second and start it back up again. Okay, we should be back. So I've now changed it to 30 frames a second with all the same settings. Everything's still exactly the same, but now we're at 30 frames a second instead of 60. Matt K says there's a 30-second delay. There shouldn't be a 30-second delay because I have YouTube here set to low latency mode. Yep, see here? Low latency is selected. So what you might need to do, here's a cool hack actually you can do. If you're ever watching a live stream, click settings and then click playback speed ×2, and basically that will allow you to fast forward up to as live as possible, and then it will revert back to ×1 speed. Everyone says it looks the same. Yeah, I don't know. I'm going to change it back to 60 anyway because it's better for my Logitech cam. So now back at 60. Yeah, I'm not sure what other settings to change really. Look, here's all my OBS settings. I've got everything relatively high. So I did have, I've got variable bitrate, 6000 kbps, max bitrate of 8000. I think YouTube recommends between 4 and 6000 for streams. I've got medium quality. If I set this to good quality, it tends to be choppy. I've got low latency because again, I think high quality was causing it to be choppy. Although I can try changing this to good quality and see if it makes any difference. Look ahead, I've got that deselected because I think that was what was making it be choppy as well. Base canvas 1080p, 60 frames a second, no downscaling. So yeah, I'm not really sure what could be causing it to look bad. If you put 1080 and it buffers, then your internet is just too slow, my friend, Harry. Unfortunately, not much you can do about that. The video is only 14.144. Yeah, that YouTube does that. YouTube has started changing all of your resolutions by default to lower settings, and then seeing who changes it back. Basically, they're trying to reduce bitrate across the board. Because bandwidth is expensive, so they're trying to reduce bandwidth, and what they found is that 70 to 80% of users don't change it back when YouTube also changes it to like 480, because most people are watching on their phones, and a lot of people have glasses or have like phone protector screens or cracked screens, and really they can't tell the difference. They don't care. So what YouTube have done is they have rolled out a thing where everyone's settings got changed to much lower, and then if you change it back to 1080, it stays on 1080 for a bit, but then you might find it goes back to 480 again a couple of times. But if you keep changing it to 1080 enough times, it should stay there. Where can I get some iOS 2092 at an affordable cost? Prince, that is the $1 million question. That is the question. Yeah, there isn't really an easy answer to that. We are still in the chip shortage. Parts are still very expensive and hard to get hold of, I'm afraid. So yeah, not really much you can do about it other than just keep looking online. Don't be tempted to buy from AliExpress or eBay or China, because they'll often be fakes or failed batches. What are we repairing today? Today we're repairing a Sundown audio SAZ 3000. This is a really ancient old ass half bridge thing. I'm going to see what's up with this. That thing with YouTube changing the quality is that is actually a thing. I've not just kind of made that up or decided that. They are actually doing that. Confirmed by some people that have inside knowledge with YouTube. It's not a big deal. It makes sense though, doesn't it? Like, if you've got as many users as YouTube does, and a lot of them not really caring whether or noticing whether it's on 1080 or 720 or 480. If you're running a business, which YouTube is a business, then bandwidth is expensive, and if your user base doesn't realize or care too much, then yeah, lower the bit rate for everyone. And if people change it back, then that's cool, they can run the high bit rate, but if they don't, then it's cheaper for YouTube. All right, what we've got going on in here then? Really old circuit, this. The TL494 is in headers, which is interesting. It's in a header. Right, so let's have a little go through this board. I'm going to take it onto this camera. Right, so what do we have here? Power supply section. We have some pretty big transformers here for a 3.5K. Lots of paralleled 064N MOSFETs in the power supply. This is an old girl. It's definitely been repaired before, probably a number of times. Then we have the rectifiers here. Looks like they've been out at some point as well, for some reason. So yeah, rectifiers out, have been out in the past. Output FETs. Driver card, that's not original. This driver card is an orange and black colour. Looks like it's come from a ground zero. So that's been replaced at some point. These capacitors all look original. That 7812 looks like it might have been replaced at some point as well. Okie dokie. So what we got here then? Why is this here in the workshop today? What problem does it have? First thing we do is get our multimeter. Before we do anything is check for shorts on the output FETs. So check over here. I still don't have, I don't have a multimeter cam hooked up, but I do have this camera now that I'm using as a handheld cam. So maybe if I just put this in front of the multimeter, then you can see what the multimeter sees. That might be a good shout. Yeah, let's put that there. And then add a little thing for that. Maybe I'll change the pedal. Sorry guys, I'm just kind of changing the setup a little bit here today. It's just a nice chilled stream. So on my foot pedals, I've got the scope cam as one of the hotkeys, but I think I'm actually going to change that to be a different hotkey so I can quickly switch to the handheld cam. Here we go, hat cam. So if I change the hotkey for that one to be that, and then change the hotkey for the scope cam to be a different one. Side chat, start, web, correct, audio, RTA, SFX, scope cam, here we go. Scope, change that to that one. There we go. Okay, there we go. Cool. So, yeah, to check the output FETs, just going to go ahead and have a look. So, not got a short on this side. How about over here? Nope, looking good between all three legs. Cool. And how about this side? Okay, cool. Yep, no shorted output FETs, which is lovely to see. Means we're probably not going to have any issues, any headaches with the output section. Okay, let's check the power supply FETs. Okay, so flip the probes round because we're charging the power supply caps there. There we go, no shorts. Okay, so it doesn't look like we've got any shorted FETs, which is interesting. So what we can do now is safely add some power to the board, try and power it up and see what it's doing or what it's not doing. Yeah, the battery does need changing in the multimeter. But I don't. The thing is, right? People are always saying, "Oh, buy a Fluke multimeter because it's very, very, very accurate." I don't need my multimeter to be accurate. Like literally, I don't ever look at the exact numbers that are on the multimeter, and they don't mean anything to me. When you're repairing an amplifier or something like this, all you need to do is make sure that the gate, the things you'd use a multimeter for, make sure that the resistors are within tolerance. Okay, resistors in amplifiers like this generally have a plus minus 5% tolerance. So provided my multimeter is within a plus minus 5% tolerance, then that's really all I need to know. If I'm reading a 47 ohm resistor, it could be anywhere from 46.8 to 49.5 or whatever. So if I see a 47, 46, 40, 48 on the multimeter, then that resistor is fine. And if it's not visually discolored, then it's fine. If I'm reading MOSFETs and stuff, all I need to do is make sure that there's not a super low resistance there. So provided on diode mode, I'm reading above 400, it's going to be fine. If I'm reading like 50 or 80 or it's constantly beeping, then that MOSFET is bad or the drive circuit is bad. Like, I don't need crazy accuracy. The multimeter is just a tool for telling me whether the part is good or bad, and that can be relayed to me without crazy accuracy. So actually, yes, exactly. Every single Fluke that I have tried, there is a delay between when you touch the wires and it giving you an audible beep. One of the most frustrating things for sure, especially when you're trying to trace a circuit, like follow a trace through the board to figure out where it goes, and you're just very quickly brushing the multimeter probe across various pads and stuff. Yeah, you need the beep to come absolutely instantly as soon as you touch the wires together. And yeah, lots of the more expensive auto range meters, I really hate that they have a delay. And also, I really can't stand auto range meters. They drive me nuts. Like, I want to tell the meter, I'm expecting to read a value in this range, and if the value that I'm reading is outside of the range, then the meter will just display a 1 or OL, you know, whatever it is. That will that will more quickly tell me, oh, okay, this part is bad or not reading how I expect it to. If it's an auto range meter, then you put the wires on and you've got to wait for like a good amount of time for the meter to figure out, oh, okay, what range is this in? And it's all auto ranges and it gives you a number on the screen. And then I've got to look at the screen and work out whether it's a small M, a big M, a K, or whatever, as to what range that number's in. No. I am telling the multimeter, I am reading what here should be a 47 ohm resistor. Therefore, bang, 200 ohm range. If it's out of that range, it displays a 1. Easy. Sam, I unplugged the RCAs and static went away. RCAs are new. So the issue is signal side. So the static noise is coming either from the DSP or the head unit or something on the signal side. It's highly unlikely to be the RCAs themselves, but it will be something along the signal path. Some device that is coming down the signal line. Beefy's Ghost says, what do you charge to look at sound distrom in the USA? I don't work on amps from overseas, unfortunately, because the shipping is just too expensive. So there's lots of competent technicians in the States. I know a lot of people like find me from my videos and stuff like that, and they're like, oh, I want to send you an amp. But honestly, there's loads of technicians in the States that are as good or much better than me. So, and it's going to be so much cheaper to send it to them rather than shipping it over to the UK. And obviously, if you send an amp to the UK, I can't really give you any warranty on it because the shipping is so expensive. If anything happened to it as a result of something that I missed or did wrong, then I can't easily say, oh yeah, just post it back to me. It's another like $300 round trip. So why is the overhead cam that shows the amp shaking? I'm not aware of it shaking. Oh, it does look a bit flickery, doesn't it? Is that flickering to everyone else? Well, it is flickering a bit, isn't it? I've never noticed that before. Right. The overhead cam, okay, because it's a cheap Chinese capture card, it's 1080i, so it's interlaced, right? So I've just disabled interlacing. This is what it looks like if I disable interlacing, okay? So if I now, sorry, deinterlacing. So if I put deinterlacing back on, I've got various different modes of deinterlacing. Okay, that's discard, which looks like ass. This is retro, which looks okay to me. Don't know if it's a bit shaky. This is blend. Looks very blurry. This is blend times 2, looks even worse. This is linear, looks very choppy. This is linear times 2, looks better. Linear times 2 looks okay. And actually linear times 2 doesn't look like it's shaking, so maybe I'll leave it on linear times 2. Okay, so got some power into the board, so let's power it up and see what we've got. Turn the scope on for the first time today. Turn the power supply on. Going to turn the voltage down to about 9.8 volts, just as a nice low voltage to power it up with first. Keeps the rail voltage nice and low in case there is a problem. It's less likely to cause damage. Okay, so let's first of all pulse the remote a couple of times just to build a little bit of rail voltage. Make sure the rail voltage is all in the correct place. So probe the power supply FET here. We should see a little pulse as we apply the remote. There we go, little pulse. Okay, now let's take it over to the output section, and we're checking to see whether we have rail voltages in the correct places. So we've got high side with positive rail in the middle pins, that's correct. And low side with negative rail on the outer pins, that's also correct. Check on the other side. This should be low side with nothing on the middle pin, high side with positive on the middle pin, nothing on the outer pins. Okay, that all looks good. So now we're pretty much safe to go ahead and power it up fully. So we're just going to probe the low side drain of one of these MOSFETs here. Give you the scope cam, and yeah, hit it, see what it does. Okay. Whoa! So we had output switching, but my god, the frequency is all over the place. And some interesting sounds coming from the board there. Whew! Okay, so then we didn't get any output switching at all for a moment, and then when it did come in, it was all over the place again. So yeah, it is not happy. I would say the drive circuit is very, very unhappy. So we do have an output section fault somewhere we need to take a look at, and might be a bit of a deep dive. So how to approach this one then? No dead output FETs, just a drive circuit fault. What I want to do is I want to get the drive circuit up and running without it switching the MOSFETs. I don't want it to be switching the FETs on and off because it clearly has a problem, and I don't want to damage the FETs unnecessarily. So what I'd like to do is I'd like to disconnect the MOSFETs from the drive circuit so I can power the drive circuit up and look at the pulses that it would be sending to the MOSFETs without it actually trying to switch them. So the sounds that you heard were emitted from these capacitors here. And the reason you get that is as the Class D switching starts and stops or changes frequency, you get these very sharp high voltage spikes which actually are sent through the inductor. They don't get filtered by the inductor because they're lower frequency. They're either a spike, which is like DC, which the inductor will pass, or a lower frequency, which the inductor will pass as well. And when that is passed by the inductor, because it is still like a spike, will be passed to ground by these capacitors. So these capacitors then emit like a noise. Like if there's a sharp spike through the inductor will pass it and the capacitor will ground it. And you get a noise emitted from the capacitors as a result of that. So the noise was coming from the capacitors. That's pretty normal with this type of fault. So yeah, first thing I want to do is definitely isolate the output FETs from the drive circuit. It would be very unusual for there to be a trace problem on the underside of the board, but I suppose we could take it apart anyway, just to double check. What I'll do first though, I think, is like this feels very solid. I don't think it's not a drive board connection issue. The switching frequency was just completely wrong there. So I think I'm going to disconnect the FETs from the drive circuit first, power it up and see what it looks like. Okay, rail voltage has disappeared now, which is nice. So we're going to take the soldering iron and just lift all the gate resistors. Now, if you've got a situation like this and you need to isolate the MOSFETs from the drive circuit, sometimes you can just remove the gate resistors, just lift them up, but you can only do that if the circuit has pull-down resistors for each MOSFET or for each bank of MOSFETs. So if you disconnect the gate resistor, then that will cause the gate of the MOSFET to not have a direct connection to the drive circuit. If there's not a pull-down resistor as well, that's connected to the gate and across the gate and source, then stray charge can build up on the MOSFET gate leg while it's disconnected and just floating. If it's not connected to anything and it's just kind of floating there, not connected to any circuit, it will build up its own kind of charge, and the MOSFET will spontaneously turn on and dump the whole entire contents of the rail capacitors to ground through the MOSFET, killing it. So if you're lifting gate resistors, you must make sure that there are pull-down resistors between gate and source, otherwise you're going to have a bad day. So I'm just going to start by just lifting one leg of each of the gate resistors away from the board here, powering it up and seeing what it looks like. There's two things that will happen as a result of doing this. First thing that could happen is the low side drive looks absolutely fine with the gate resistors removed, in which case it will be a high side bootstrap fault, because if the low side looks good and is the correct frequency and doesn't glitch or anything like that, then the only other thing it could be is a high side bootstrap issue. However, if the drive does look janky and bad, even just on the low side, with all these removed, then yeah, it's going to be a op-amp fault on the driver card, or a drive IC failure, something like that. Mr. E100, whereabouts are you, buddy? If it's the evening there already. So Annibal says that there looks like there might be some burn mark here next to the driver card, and yeah, it does look like that. This amp definitely has been repaired before, so not sure whether this burn mark, this soot on the board, is new or old. It does look like it hasn't been touched before though, so it could be new, but I don't see any component around that area. Like, looks like the soot may have come from underneath this resistor, which doesn't really make a great deal of sense. But maybe it would be worth pulling the board out of the heatsink anyway and removing that resistor and checking it, because yeah, I agree, it does look a bit suspect, doesn't it? Let's just confirm the health status of the drive circuit first, but then I think we'll pull it out of the case anyway. Just have a look what's going on underneath that resistor. Sam, you know the electronics weirdness we talked about, like the Mobo stuff and your PS2 stuff. Have you ever had any experience like that with amps? Probably, yeah. Like, I can't think off the top of my head, but there's definitely been times with amplifiers where there's been intermittent faults, or faults that don't make a lot of sense. So if you're removing gate resistors to isolate the output FETs, and you are unsure as to whether there are pull-down resistors in the board, all you need to do is, after you've removed all the gate resistors, just take the multimeter onto 200k. Let's try and get it to focus on the multimeter here. I think it's wanting to focus on the background. Come on. There you go. And just measure across the MOSFETs, gate and source. And as you can see there, we've got 100 kilo ohms between the gate and source of all of these, which means that they have pull down, which means that we're safe to run the amplifier without the gates connected to the FETs, and there shouldn't be any issues. Okay, so let's power it up again. Now I've removed all the gate resistors. One gate resistor that I've missed, so let's just remove that real quick. Minus 3 dB, it's kind of difficult to say whether the newer amps are reliable because they're new, so they haven't really been out long enough for people to really say if they're going to be reliable or not. I haven't personally had any of those amps on the bench yet, but I don't think there's really any in the UK yet, so I wouldn't really have seen any. And you can't really tell how reliable a circuit's going to be just by looking at the guts. You need to actually get it on the bench, have a look at the waveforms, have a look at how stressed each component is and stuff like that. Stephen Nelson, sounds like you might have an auxiliary voltage supply issue, so I would check the voltages on the op amps in the preamp circuit. Make sure that you have plus 15 on, I can't remember which way around it is on the op amps, but basically pins 4 and pin 8, so pin 4 and 8 of the op amps in the preamp circuit should have opposing supply voltages, so plus 15 volts on one and minus 15 volts on the other. Could be plus minus 12, could be plus minus 16, something like that. They should have opposing bipolar supply voltages on pin 4 and pin 8 if it is an 8-leg op amp like this. If it's a larger op amp like a TL074C, then it's a couple of the middle pins, can't remember the exact values, the numbers of the pins, but yeah, check that you've got bipolar supply on the op amps. If you don't, then you need to trace that back, see where that supply is generated. Okay, so that is all of the gate resistors removed. So let's power it up and see what the drive looks like on the low side. That's just over here. Okay, so we're not getting any pulses on that side. We're just getting a bump up to, well, fully on. Now, that is sometimes normal. That doesn't necessarily mean that there's a problem. However, more often than not, the amplifier will be trying to oscillate here and will be giving you little pulses on the low side. So that's interesting. Next thing to check is, if we have a look over here at the driver board itself, let's get my wire here for the camera untangled. And if we have a look at the driver card itself, one of these middle set of pins will be oscillator output, which means you should see some little pulses on there, and there'll be the oscillator output from the op amps. So the op amps in the middle here of this driver card, they generate the pulses that the output section works on. They listen to the audio input from the preamplifier section, convert it into pulses, and send it on to these drive ICs. So I think it's this end pin here, but it can be different depending on what driver card it is. You should see a little square wave that's about plus minus 5 volts peak, which will be the oscillator output. So let's have a look and see if we've got that on any of these pins here. Okay, nothing on that one. There's our 5 volt supply. That's nothing. That's nothing. There's our negative 5 volt supply. That's also negative 5 volts. And that's positive 15 volts. Okay, so there's no oscillator output, and we've also got 2 pins with negative 5 volts on them, which is not a good sign, I don't think. I'm pretty certain from all of these I've repaired in the past. You have obviously the 2 pins with the plus minus 5 volt supply on them. One pin has the plus 15 volt supply, And then yeah, you should get an oscillator output, which doesn't look like there is. So I would say that there is an issue with the op amps on this driver card here. So I think that's the first thing that we should change, is just change the 072C and the LM211 or 311 in the middle there, and see whether that solves it. See whether we get any change after replacing those two parts. Is your 3D printer going? No, not at the moment. Ari, you don't need 12 volts there. Not on those pins. You need 12 volts reference to negative rail on the outer pins of the driver card for each of the IRS 21844S, but you don't need plus 12 volts on the middle set of pins for the driver card. You need plus 15, plus 5, minus 5, and ground. That's all you need on the driver card on the middle pins. Thanks very much, TJ Rome. Appreciate that. Oh, Stephen, sorry, I forgot to add, I do have VCC plus and minus 15. So in that case, you just need to go ahead and follow the audio signal through the board and figure out where it gets lost. So it might be as a result of a bad switch or potentiometer. So take your isopropyl out first and just clean up all the switches and knobs on the amplifier. Could be preventing the signal from passing. You could have a bad op amp. Basically, if one of the op amps goes bad, what can happen is it can leak the supply voltage, one of the supply voltages, either plus or minus 15 volts. It can start leaking that, really make its way through the preamp properly to the output section. So I would be willing to bet that one of two things, Stephen, on your amplifier is either the switches and potentiometers are bad, or one of your op amps has failed and is leaking DC into the signal path. So to figure out whether the op amp has failed, obviously you're probably going to, best thing is to have a scope really, but you can do it with a multimeter. You just want to put the black probe on the RCA ring, the RCA ground, and then go around all the op amps, and you should only see a DC voltage, like a significant DC voltage, on pin 4 and 8. If you see a significant DC voltage on any of the preamplifier op amps on any of the other pins, other than pins 4 and 8, or whichever pins are the VCC for the op amps that it's using, then there's an issue there. And it doesn't necessarily, like, if you find some DC voltage on the op amps, it might not be that op amp that's bad, because the DC might be flowing through the circuit from another bad op amp. So if you've got a thermal imaging camera, you can put the thermal imaging camera over the board, and usually the failed op amp is the one that's running hottest. But trial and error of removing op amps. And actually, I'm struggling with an SD12K. Output doesn't work. Change drivers FET's okay. Is there a way to force it into oscillation? Yep, there's a couple of diodes that, so you can remove those diodes. Try powering up and see whether it forces us. Only start oscillating when everything is perfect. And to get it to oscillate when there's a fault, so you can actually find where the fault is, can be a bit tricky. Possibly removing the op amps here on this driver card. So I'm just going to stand the board up right here. So we need to remove this one and this one. Now these op amps are very sensitive to temperature, which I have found over the years of doing this. Oh, I just got an error on my soldering iron station. I've never had that before. The screen just came up saying error. That's never ever happened before. Okay, it's powered off and on. Try again. There we go, it's better. So if you're having buffering issues, yeah, it's probably going to be your side. For me, OBS tells me if I'm dropping frames due to poor internet connection or due to overloading my encoder. So at the moment we have a green box, which means that everything is okay, and we have 0 drop frames, 0% drop frames down here. So the stream's good my end. If you're having buffering issues, lower down your connection settings. Yeah, look, YouTube also saying excellent connection, so everything's good my side. So if you're having buffering issues, it's going to be your side. Although a lot of people do seem to be having buffering issues, so don't know what to say about that. Anybody not having buffering issues? For whatever reason, are very cooking up new parts unnecessarily, because in my experience that has actually caused issues with the new parts. It throws them out of tolerance and they don't oscillate properly at these higher they put in. I'm actually going to tack them in with the just heat the legs and not the actual die itself. So I'm just going to reflow the solder pads here, get some fresh solder on. Ooh, that's a big blob, that one. I've printed the enclosure for Boom or Bust episode 4. Unfortunately, it wasn't that successful. I mean, it will be usable, but I switched from a 0.4 nozzle, sorry, 0.6 millimeter nozzle. And I don't know if it's just, obviously, with being a bigger nozzle, it can't do details as well, but it's, yeah, it kind of looks like under extrusion, which I accounted for. I knew that going up in nozzle diameter would mean that the hot push out more filament. So I reduced all the printing speeds to nice and low, up the temperature, you know, changed some settings to a bit. It will still be fine to use for episode 4, but I either need to find a solution to make it look better, or just have to go back to the 0.4 nozzle. Doesn't look like it's shaking to me. Looks, is it shaking for anyone else? Looks dead steady for me on the screen here. So let's grab some more op amps and drop them in place, see what it does. Okay, there's a fresh 072C. Let's plop that down. Now I need a 211 or 311. The audio pipe is just sitting on the back shelf. I've just got too much on at the moment to devote any time to it. Although I did buy some secondary wire for the secondary transformer, so I think I've got enough wire now for the secondary wind of the transformer, so I just need to wind it onto the core and make sure that I've got enough wire on there for the secondary wind that I need. Just currently digging through my parts for a components in the UK. RS Components, Farnell or Mercatio. If you this, then you can get parts through Mercatio, which are usually quite cheap. Is that a 211, 311? I can't see, that one's been scraped off. There is a fresh 311. Nice, I'll have that, thank you very much. Okay, so we're now back at 30 frames a second. So guys, the guys that were struggling with buffering, let me know if that solves it. So yeah, OBS did change to 30 because you can see down here, now I'm at 30 FPS, yeah? So you might need to refresh the YouTube page to make it go down from 60 to 30. Or it could be something with the stream settings, I'm not sure. But now I'm definitely streaming at 30, but maybe YouTube won't update it unless I start a new stream from a new, a new stream window or something like that. But I'm definitely streaming now at 30, which might help you guys if you're struggling with buffering. So I'm going to remove this 311. This is from a JBL driver card, just to test in here. If you can prove you're a business, you can buy parts from Mercatio in the UK. But the best place to get things from if you're just an individual is RS Components or Farnell. But that's only if you're in the UK. I don't know what places there are in other countries. I'm just speaking from experience in the UK because obviously I don't buy parts from other countries. So. I'm removing this 311 just by heating around it. I'm not actually applying heat directly to the chip because they are very, very delicate with temperature. So there we go. Let's get you cooled back down again, mister. Guys, I have a stream question for you. If anyone knows about live streaming, how do I set up Nightbot? Actually, I could just ask Google, but seeing as I'm talking to you guys anyway, I'd love to set up Nightbot on the streams so that people can ask frequently asked questions like, what amp are you working on, etc. What's the situation with the audio pipe, blah blah blah. Common questions that I get. I'd love to set up a bot to answer those. So yeah, the reason I'm not using hot air for this is because these are extremely sensitive to heat, these parts, and had bad experiences with them in the past as a result of that. So I'm just going to tack them in by hand with the iron. If I can. Seems to be easier said than done. Right, now how am I going to get to these underside ones? Okay, I think that should be good. Let's do the wiggle test. I have to get my camera down and then double check. But yeah, for anyone that's just joined, the reason I'm not using my hot air gun for these is because these parts are super sensitive to being heated up for any duration of time. So I just want to do it with the iron because I've had bad experiences before. Is Nightbot free, or does it cost money? How's it going, Kenneth? Thanks for jumping on. Do you have any money mods? What the heck is a money mod? Right, let's see whether we've actually managed to solder those by hand and not make any solder bridges. So we know they're good that side, but it's the other side that I want to double check on. Seems all right. Okay, possibly have succeeded there. I just want to have a proper look in there though and just double check that the legs are really nicely soldered. Thanks for the shout out. That looks complicated work. It's just fiddly. I would usually use the hot air gun for this kind of thing, but like I said, it's very, very temperature sensitive, these chips. So yeah, it looks like I managed to solder all of those quite nicely, I think. though it is really hard to tell, especially on the back ones down here. I'm going to take the side panel off so that I can get a better view. Now see, risers are a really bad idea because these amps are subjected to a very vibration heavy environment and you don't want to leave risers in. And to strip the board out of the heatsink, remove the driver card, do this work, put it back, that's a lot of extra work. That's like really high, like a lot extra work. That would cost the customer a lot more in my time. Whereas yeah, just doing it like this real quick, provided we make a good solder connection, is yeah, it's no problem at all. Okay, here we go. So we can see a lot better now into here. Yeah, man, absolutely solid. Okay, cool. So we've still got the MOSFETs removed from the drive circuit by lifting the gate resistors. So all we need to do is power it up now and see whether our new op amps have allowed there to be switching on the low side gate. So let's get some oscilloscope probe. Flick the power supply on and have a look, see if we get low side switching. Okay, there's negative rail. Okay, so still no low side switching. We just have that bump up to fully on the MOSFETs. What do we have on the driver card though? Negative 3.7. So that negative 5 that we saw before, instead of the oscillation, has changed. It's now only negative 3.7. Right, I'm going to inject some signal. Okay, I want to see what happens if we inject a signal and see what happens to it or where it goes. Let's connect the end plate board back up and inject some RCA signal. See what happens. So I'm going to give it about 40 Hertz, and we're going to see whether the 40 Hertz makes its way to the driver card and see if it makes its way out. So low side gate again. Now got 40 Hertz going into the board. Okay, so yeah, we're not getting any 40 Hertz pulses on the gate path there, which is not a good sign. So yeah, definitely still a drive circuit fault here. Let's probe the oscillator output pin of the driver card. Still just getting negative 3.6 volts on there. It's really interesting. That would really only be a problem with the op amps there on the driver card. Provided the signal's making its way to there, and we've got plus minus 5 volts going in here, that should literally be it. One thing that I have experienced before actually, so obviously I've got brand new 072C op amps here. One thing I have experienced before is, for some weird reason, the current generation 072Cs, whatever ones that I ordered that are like brand new, aren't compatible with this older style of circuit. Not sure why, but I have had that experience a couple of times. So what I might do is I might just try replacing that 072C I just fitted with an older 072C from a donor driver card here, and see whether that makes any difference to how this is behaving. Just because that is an experience that I have had over the years. That, yeah, for some reason sometimes these 072Cs that these newer ones do weird stuff in these circuits. So I'm just going to have a dig through my donor cards, driver boards here, and find myself a spare 072C. That is an older style one. Here we go. Yeah, there's one on this driver card here. I'll take off. Again, I'm going to try and take it off just with the iron and not get the hot air involved, if I can. See how I'm just applying the heat very, very gently here, just for like a couple of seconds, and just pulling at the thing to walk it off the board. I don't want to apply the heat for too long because they don't like it, these. There we go, that's one side off. There we go. And these driver cards are all dead donor driver cards, so we're not too worried about the pads, even though they are actually fine on there. We're more worried about the parts. So let's swap that part out for this one I've just taken off. think I'm going to remove this one with the hot air just because it's going to be a massive pain to try and remove that with the iron. I always have to try and do it quickly and gently. Got to get these back ones now. There isn't really an easy way to show the back ones on camera, so I'll just have to hide behind the board here and do it like this. A bit more flux. Cool, that looks alright. So different 072 op amp fitted now. See if that makes any difference to how this is behaving. Just because I've seen that once or twice before with the newer 072s that I've used. So power on. Probe the low side gate. And let's have a look. Okay, so we've still got a bump up from ground or negative rail to fully on. What do we have on the oscillator output pin? Still negative 3.6. Okay, I think it's time to pull the board and see what's going on. Because we're not getting anything on any of these. Let's just check we're getting our plus minus 5 volts. There's -5. Hang on a minute, it doesn't look like we're actually getting ±5 volts to the op amps themselves. We're getting it on the pins here into the board, but doesn't actually look like this 072C doesn't look like it has its voltage on it. Look, so pin 4 should be, I think it's ±5. We got nothing on there. And pin 8, which is this one here, pin 8 is +4.9, but pin 4 should be a -5, which is not. Huh. So the supply voltages are on the pins here for the driver card, but not actually making their way to the op amps. Let's just double check they're definitely on the pins here to the driver card. -3, -5, nothing. Oh, +4.9. Ah, there's a little bit of a waveform there. Very, very janky looking waveform on this pin here. So we should have this pin here is +5 volts going into the op amp, and this pin here should be -5 volts. So that pin there, I don't know how well I can really show you this because it's quite difficult to see, but I'll try. So these are the op amps that are generating those pulses. This pin right here is supposed to have -5 volts on it, but it doesn't. We do have -5 volts coming into the board here. So for whatever reason, -5 volts isn't getting from there to there. See if we can figure out why. Could be a bad via, could be a bad trace. The solder bridge on the bottom of the op amp is actually a jumped trace, but this amp seems to have, that driver card seems to have been repaired so many times that that little trace has actually had the laminate worn off it, so the solder just accumulates on the trace in quite a big blob. So it looks like a solder bridge, but it's actually the two traces are meant to be connected together. Okay, let's take our multimeter and have a look and see if we can follow that trace and see where it goes, see where it's supposed to go. I'll try my best to show you guys, but this is quite tight in here. So what I'm going to do is going to go and follow the traces and the vias from the back and the front of the board. So I'm going to switch between these two cameras and hopefully you'll be able to see enough to figure out what's going on. Maybe I could zoom in. It will look a bit pixelated, but I could try zooming in on this one. It does look a bit pixelated, doesn't it? It doesn't seem to focus very well. So we're going to start off here, which is where we should have our -5 volts at the op amp. Okay, on pin 4. And we're going to go to the back of the board and see where that pops out. That's there. So then we follow that trace from there to there. That then should pop out. Is it Is it there? Looks like it should pop out there. Yeah, pops out there. Goes into that one, this op amp, which I don't think it was. Ah, see how it is actually now making continuity to the trace on the board. I wonder whether it was just a bad via. Oh wait, now it's not. Ah, it is a bad via. Oh wait, no, we have continuity in that one, but not that one. And that via is that one. That doesn't seem to have continuity. Oh, it does now. Yeah, I think it's a bad via. Yeah, seems to be a bad via on the driver card, because it is making a connection when I like push it with my multimeter probes, but not when I release it. So we're going to go ahead and reflow the vias on the driver card with a bit of flux, a bit of fresh solder, back and front. And I think I'm probably going to do all of them, because if these are on their way out, then chances are some of the others are as well. Unfortunately, the camera is very much in the way of where I need to be. So that's the vias on the back side reflowed. Now let's go from the front as well. You can see the solder has actually already worked its way out the front of the vias on the front of the board. That's a good sign. That means it's filled up nicely. Just freshening up some of the other vias that I can easily get to here as well. Okay, let's check with the multimeter that we do now have continuity between the negative 5-volt input pin and the supply pin of the op amp. Now that we've reflowed the vias. So that's this one here. There we go. Continuity. So in theory, provided that was the only issue, if we power this up again now, we should have pulses on the low side of the FETs here. Let's see what we got. See if that's helped at all in any way. So probe the low side gate, turn the scope up a little bit. Okay, we still have this big bump to positive drive. What do we have now on the oscillator output pin? Okay, so now we have the correct voltage, negative 4.6 down there on the op amp. That's correct. So that's all looking good, but we're still not getting oscillation output. I wonder whether the negative 5 volts not being there has damaged the op amps in some way. So I might need to replace them again. Now that we've actually repaired the bad via. Let's just put some. Let's just put the RCAs back on, and let's just apply some signal and see whether it makes its way through the board now, or whether it's still the same. Okay, so yeah, still nothing. So I reckon it's possible that the op amps have been damaged by the fact that there was only one of their supply voltages there. I have to say, I was really thinking that was going to be it. Yeah, okay. I'll start off by replacing the 311. And then I'll power it up again, see what happens. And then I'll replace the 7.2 again. So we've got negative 5 volts now on the op amp. That's all present and good. So we don't need to inject it. I'm wondering actually if I've just got a spare one of these driver cards that I can just swap out, because if the vias were kind of bad on that one, they could all be going out. Let's have a look, see what I've got. Is that one a direct fit? It looks like it might be. That one looks like a direct replacement. Yep, that's exactly the same. So I do have a spare driver card here I can populate. It's just got a few missing parts. Just needs the 21844S's and reflowing the 072 and 311, I think. Yeah, everything else is present. Oh, there's a couple of resistors missing on this board, so I'll have to replace the resistors. But yeah, this one's pretty much good to go. Worst case. And there's also another one here that's missing loads of parts, including its legs. So I've got a couple of spares. Prince says, yeah, the op amps aren't easy to damage. I know, this is what I'm a bit confused about. They're easy to damage with heat, from my experience. But apart from that, they're quite hard to damage with actual electricity. Right, that's a different 311 back in the board. See what that does now. See if it makes any difference. Ah, there we go. Got something. Hey, so 311 was bad. Now we have PWM on both banks of here. Okay, excellent. Let's check the health status of the PWM output from the op amps, because if that's a funky wave shape, then we might still have issues with the 072, for example. Okay, that looks nice. Excellent. So a couple issues then. We had bad via. One of the op amps wasn't getting its negative 5 volt supply. And we had bad 311, which is one of the donor ones that I fitted, which I'd be extremely surprised if it was bad from the donor board that I took it from, because that was from a part of the circuit that didn't get affected by what failure that amp had before. I'm wondering whether the 311 got damaged by whatever imbalance was going on when the negative 5 was missing from part of the circuit. Something along those lines. So cool, now we have good PWM with the low side gates out. So the next thing to do would be to connect up the gate resistors back to the board and see if it actually switches the fetch reliably and plays audio. And if it does, so we would have done that with all without having to take the board out of the heatsink, greatly reducing the cost to the customer on this one. So let's wait for the rail voltage to sink down a little bit. We've got 17 volts still in the rails. Turn the hot air gun off. A little bit of fresh flux on the gate pads. This is one of the things you want to look out for when you're buying an old amplifier. Like, a lot of people have a lot of desire for, you know, some of the older half bridges and stuff like that. Like, this is an old amplifier now, and these issues do creep in. The older the amplifier you're buying, the more likely you are of getting issues, unless it was built like an absolute tank, like an old Technics from the 80s or something that just keeps on going, or some of the old Rockford amps just keep on going. Especially through-hole components. Anything that is old that has surface mount components, I would be wary of buying. Alright, cool, let's get these gate resistors resoldered and see if it switches the FETs now then. I'm hoping that these output MOSFETs weren't stressed or damaged by this drive circuit issue while it was with the customer, because yeah, none of them are shorted, they are all fine. And they did switch alright for a brief moment earlier, but I really hope that they are not damaged or weakened by whatever crap was going on with this drive circuit while it wasn't getting its correct supply voltages. Yo, Attic Chop Shop, what's going on, buddy? Stephen says, I'm hoping signal makes it oscillate. Are you referring to my amp or the one that you are working on? Okay, 1, 2, 3, 4, 5, 6 this side. 1, 2, 3, 4, 5, 6 this side. Cool. They're all resoldered. Let us power it up and get the output side switching. I'm going to connect a load to the amplifier as well. Class D amps don't like being idled without a load connected. So it's always a good idea to connect a load if you're going to be idling the amplifier. Ellie Schofield, how's it going? Okay, cool. Got a load connected at the speaker terminals now. So all FETs are connected, fire it up on 9.8 volts. Safety goggles as always. Double check for solder bridges one last time. Or anything funky like that. Cool. And let's go. There we go, output switching, looks nice and clean, 1.9 amps worth of idle current draw. It's now switching stable and good. We're locked in at 100 kilohertz. It's power the amplifier off just for a second. Going to go up to 12 volts. Okay, power up again. Looks good. 112 kilohertz now. And up to 14 volts. 14.6. Yeah, looks good. Excellent. So that was a bad VIA on the driver card that caused that. Attic says, "Oh, I feel kind of dumb. I asked Hexibase on Patreon about participating boom or bust. Went to it this morning, and the Q&A is still a month away." Well, that's good because it gives me more time to put out more episodes of Boom or Bust. So Hexibase can get better ideas to what we're doing. Alright, cool. So let's wait for the rail voltage to sink down a little bit on that, get the end plate back on, and move on to something else. What we're going to do next, guys. Next on the bench, we're going to have probably a Vibe Black Death M21K, which is a 10,000 watt RMS Korean full bridge. It's Zenon's answer to full bridge, and they're not that great. So yeah, probably grab those out next. What's your time divider on your scope? At the moment it is 5 microseconds. Let's have a quick look at the Boom or Bust enclosure for episode 4. So if you were with us earlier, I mentioned, so obviously I've been 3D printing these enclosures for Boom or Bust. I changed from a 0.4mm nozzle to a 0.6mm nozzle, because that will speed up my prints and use less energy in the workshop here, which is always good. And also the models are not high detail. You know, these enclosures, they're just boxy shapes. I don't need crazy high detail. So naturally, if anyone knows anything about 3D printing, when you up your nozzle size, you need to slow down your print speed a little bit, because you're now trying to push more filament through the same hot end as you were before, so it needs to melt quicker. It still needs to melt. So you need to slow down your print speed a bit, and you also need to. What was the other thing you need to do? Slow down your print speed. What else did I do? I can't remember what else I did. But yeah, basically, it doesn't really seem to be going that great. This is my first print with the 0.6mm nozzle, and it's very, it looks under extruded. So I've put nail polish, clear nail varnish on this to try and seal it up, but it's not airtight. You can see here that there are a lot of gaps in this enclosure here where it's not airtight. This really isn't making a good focus on there. Let me try the other camera. That's a little bit better. So you can see there that it almost looks kind of under extruded, and there's these kind of gaps in the layers here that make it not airtight. So I did go through and change a bunch of settings on Cura to better suit the 0.6mm nozzle. Like I changed loads of stuff. You can see here as well on this part, I've got this massive gap here. I think I didn't use enough infill as well, which is possibly one of the issues. I had pretty low infill percentage, but it does look under extruded. Look at the top layer of this, it's very gappy. Yes, now that's the other thing, temperature. I did up the temperature as well. So I went from 210 degrees Celsius to 220. Sounds a bit hot for PLA, but this PLA does recommend between 215 and 230. So this PLA likes getting hot. So yeah, bumped the temperature up to 220. Slowed down the print speed. This was printing at 65 millimeters per second, I think it is. Infill is gyroid, and I used 15%, or was it 10? 10 or 15% gyroid, which I probably wasn't enough. I was trying to save on material a little bit here, so it might be partly my fault for not putting enough infill in there. Yeah, the print speed is slow already. Like with 0.4 millimeter nozzle, I was easily printing great quality parts at 120 millimeters a second. So I've halved my print speed, which I shouldn't need to go half, but I have, just to make sure everything was all right. So if we have a look at the Cura print settings here, so this is my settings for 0.6 millimeter nozzle. So we've got a layer height of 0.3. Initial layer 0.3, bed adhesion's fine. Oh, this was at 0.6 when I was printing. I wasn't down at 0.5. This was just me messing around yesterday after I noticed it was coming out kind of bad. Wall thickness wasn't 1.5, it was 1.8. So wall count is 3. Top and bottom layer thickness, I've got 3 layers on the top and bottom, so 0.9 mil. 12 millimeter gyroid for the infill, 220 degrees Celsius, 65 on the bed. Flow is 100%. I've also tried 105 before, but didn't really seem to make a great difference. Print speed, this was at 65 when I printed this box. Actually, maybe I can just import the G code so you can actually see what it was. I think I can do that. Let's just go USB drive, and it was Pyramid. Here we go. If I import the G code, I wonder whether it actually tells me the print settings that this G code was made on. Print setup disabled. No, so it doesn't actually tell me what the settings were for this print. But that should have been alright. These pieces should have printed okay. So I think I've just got under extrusion going on. Because yeah, it was these lines here that were leaving great big gaps. Like here, for example, as well. Although, look at that. See that yellow line, that first line it's trying to put down? It's actually trying to put that down kind of in mid-air. It's not really got a lot to kind of connect to there, has it? Like this corner piece, for example, there. That's not actually anchored to anything. So that kind of makes sense as to why I've got issues there with that bottom piece. I think the overhang, you know, this kind of stepping was just a bit too steep, I think. So that might make a bit of sense as to why that failed so badly there. And then the top of this piece here, where I had some issues as well. Yeah, so you still got infill going on up here. And obviously, because I've got the infill quite set down quite low, there's not a lot of infill there. So that kind of makes sense why it might have sagged down. Like better nozzle cooling might have actually helped a bit there, perhaps. But yeah, let's remove this this for a second, and let's just open a random thing here, so I can go back to my print settings. Here we go. So yeah, 0.3 layer height, 0.6 line width, 3 walls, 3 top and bottom layers, 12% gyroid, 220 on the temperature, print speed 65. like I say, that was up at 120 with the 0.4mm nozzle, and it was absolutely fine. The retraction is good. Have a little bit of stringing, but not too bad. This is what everyone recommends, and that's been working fine with the 0.4mm nozzle. Shouldn't really have to change the retraction, I wouldn't have thought, for the 0.6, but maybe I do. That's about it. So if anyone can see any settings there that look a bit off, let me know. The white dots are the seams. So look what you guys said. Up the nozzle temp 5 to 10 degrees when printing with a large nozzle. Yeah. Yeah, so I did go up a bit. Maybe I need to go up even higher. So yeah, with this one, I'm going to put some, so I have started putting some nail varnish, nail polish, clear nail polish. I'll do another layer now, actually. Yeah, so this will be salvageable, but it just doesn't look very pretty, and obviously I don't want to have to do this to every box. If I can't get it good, I'll just have to go back down to a 0.4mm nozzle. It just makes the prints take forever. Can you show us the hot end? It's just a completely stock Ender 5 Plus. Dead stock. And the stock Ender 5 Plus is capable of printing absolutely fine with a 0.6mm nozzle. So I know a lot of people will say, oh, upgrade the hot end, get a Volcano, blah, blah, blah. But that's not solving whatever issue I've got here. That's an upgrade that I can do in the future that will help me print faster maybe. But the Ender 5 Plus is capable of printing absolutely fine with a 0.6 nozzle. So 65 is still kind of fast. I'm printing boxes at 3540. Oh, really? Rare. Maybe 65 is a bit fast then. Yeah, that's kind of what most people on the web seem to recommend with a 0.6 nozzle, and they seem to get good results. Maybe I'll try slowing it down a bit more then. But usually, so what I've experienced before, when I first got the 3D printer, I wasn't printing hot enough. I was printing down at 190, and when I upped the speed, what I found was that the extruder would skip. You could hear it skipping on the filament. Like you could hear the gear skipping, the wheel skipping on it, where it wasn't physically able to push it out the hot end because it wasn't hot enough. So I wasn't getting any of that at all. I monitored it for quite a while it was printing this, and it seemed like it was fully capable of shoving it out the hot end absolutely fine. I just want to see if you have the nozzle installed correctly. Okay, let's see if I can get the camera over. I'll bring the nozzle over a bit because it's way at the back. Here's a little Boomer Bus speaker. There it is, the little Peerless. It's very soft now. Okay. I'm not sure how well you'll be able to see because it probably won't want to focus. I don't know how to tell the camera to stop focusing on the background and focus on what I'm pointing at. Oh, there we go, it's a bit better. So, looks okay to me, nice and tight. Gets hot, prints, but just seems to be under extruded a little bit. So if I can't dial it in, I might just go back to a 0.4 nozzle, because that was printing really nicely. Like the most recent box that I did, the half wicked one, that was beautiful. That was printed really nicely, really solid. Everything was great. Yeah, nozzle was tightened down really well. Super tight. Well, not super tight, I didn't over tighten it, but tightened it well enough. Alright. Let's see whether the nail varnish has sorted this. I'm going to do the water test. So I'm just going to fill this with some water and see whether it drips out. Nope, still not watertight. It is leaking pretty bad. I have to completely cover it, I think. I could use the soldering iron, and I could go over it with the soldering iron so that it's like covers, you know, it sort of like closes up all the holes. But yeah, really annoying. What was the difference in time? Let's have a look, shall we? Let's have a look at the difference in time between the 0.4 and the 0.6. So if I open up that box, it was pyramid.stl, and then it was also the base. So I think it took about 8 hours or something. So with the 0.6, with all the settings that I had it set to, I think I had it 0.3, or did I have it 0.3? I think I had it 0.3, I might have had it 0.3. I think about, oh shit, I can't actually remember. What did I have it set to? I'm going to assume I had it 0.3. Yeah, that was the amount of walls and everything I had. Did I have 2 or 3? I think I had 2. I can't remember. I think it was 2 top bottoms on that one. Definitely 3 walls. And infill, yeah, about 12, 226, 65. Contraction, yeah. So with it like this, with the 0.6 nozzle, it takes 10 hours 49 minutes. It's a bit longer than I think what it was before. I think I might have had 0.36. Yeah, no, that's about right. So I think I had 0.36 layer height. So if we go back to my, I'm just gonna, yeah, if we go back to my 4mm nozzle, I'm just going to reset everything. So with the 0.4, I was printing with a 0.2 layer height, layer width 4, wall thickness, let's do 4 walls. That was what I was doing before. Top bottom thickness, I was doing 4, so 1.8. 12% gyroid, yep, temperature's all the same. Although I did actually have that down at 210, but that doesn't make a difference to the print time, so just leave that as it is for now. Print speed, so I was able to really nicely with the 0.4mm print at well over 100. So let's just go for 110. And it was printing really nice. The most recent box I did, the half wicked one, was beautiful, and that was printed at 110mm a second. Traction's the same. Everything else pretty much the same. So we were 9 hours 38 minutes before with my old nozzle with the 0.4. $15 hours. So it's quite considerably more. It's another 6 hours. And I should be able to print absolutely fine with the 0.6. Like, there shouldn't be a problem. There's something wrong with my settings or something here. So try to figure out what it is. Obviously, with the print bed consumes about 250 watts while it's maintaining the print bed at like 65 degrees. So an extra 6 hours at 250 watts is not a comical amount of energy and cost in electricity, especially with the prices how they are now. So if I can keep the print time down, it's not just about convenience, it's also about the amount of energy used to print each one of these things. Did you get a Paraflex box? Nope, no one's done a Paraflex yet. You should look at doing PID tuning on it. Any change to the hot end is good to do. PID tune. Oh, yes. Is that the is that like the distances, the ZY, the XYZ axis adjustments to make sure that it's actually the right, it's actually printing the right dimensions? Did you watch the engineering video that said scaling won't work? Like when you're doing, is it different? No. So Hexibase mentioned that scaling doesn't work to scale a box down. Let's say that Hexibase designed a box for a 12-inch. Okay, he's saying that it won't work if you scale that box down for a 6.5-inch to play the same frequencies, because it doesn't. Scaling how I'm doing it though, where we're scaling everything, including the frequencies, does work. But yes, let's say you had a really, really well-performing box for your 12-inch sub, slammed all the frequencies you wanted, sounded great, nice and transient, and you wanted the exact same experience, albeit at a lower dB level, from a 6.5-inch sub. You couldn't just scale that box down and have it work exactly the same for a 6.5-inch sub. You could scale it down if you scale the frequencies as well, but then it obviously wouldn't do the same. It would be kicking at a much higher frequency. So yeah, Hexibase is saying you can't scale boxes between driver sizes for use in the same way. What we're doing though is rescaling everything, including the frequencies, just to make it easier. No one, yeah, we've had some T-line boxes sent in. I'm going to be doing one of those soon. usually once the print gets so tall, I turn off the bed heating. So from my experience, when the bed starts getting cold, the part just lifts and just completely takes off. It doesn't actually stick once it's off. I'd love that though. That'd be great if I could turn the bed off after a certain amount of time. That'd be great. But yeah, I don't think that actually works for me. At least not with this PLA. Anyway, that's this amp done. Let's put the end plate back on. Move on to something else. Maybe I should try a test print. Should I try a test print with a few different settings and see if I can get it to look any better? What I could try and do is I could actually take this part here that's not printed so well. I could slice it so that it's just this kind of gradually increasing shape bit here, and try a few different settings and see if I can get it to look any better. Print with a brim. Yes, I do print with a brim. Look, see this part here was printed with a brim. Right? Look at this. Where the heck's my camera? So this part was printed not only with a brim, but also with 65 degrees on the hot end, on the hot plate, the build plate, the entire time, and we still have a little bit of lifting. You can see that on the corners, just where it's just lifted a tiny bit. Tiny bit of lifting. So even with a brim and with keeping the build plate hot the entire time, it still lifts a little bit. So definitely won't get away with that. It's a glass build plate. The adhesion is good for the bits that are stuck are good. Like it doesn't fully come away, but it just lifts a bit. And I think that's, to be honest, I think that's partly due to the room temperature in here. I often print overnight because so I haven't got the noise of the printer during the day. So I print overnight for convenience, and the temperature in the house drops down to about 14 degrees Celsius overnight probably. So that doesn't help. I know that is something that doesn't help. So in the summertime, it might be better. The reason that I like printing on glass is you get this beautiful smooth finish. You get this like really glossy smooth finish on the print, on the first, one of the faces. It looks really nice. Right, can somebody who knows a lot about 3D printing recommend me a test print file from Thingiverse that will help me dial in this 0.6mm nozzle a bit? Because I'll throw a quick test print on now, because I want to get it dialed in. So, I mean, this is a great test because it failed. this like ramp up here. I know a benchy is a good thing to do, but they take a fair while, the benchies. But they're not that big, they might not take that long. Let's have a quick look on Thingiverse. Because I'm going to do an Amplifier next, but I just want to get the printer doing something in the background while we're at it. Maybe I'll just download a benchy real quick. Where's the original benchy? These are all remixes. .666 recommends. Wait. Do I put that into here? Calibration cube is good. No, it doesn't work. Where do I put the thing number, buddy? Calibration cube, this one? The thing is, I don't think a calibration cube will actually help me dial in, because the thing is, the print has failed on a part where it's like ramping up in height here. So a calibration cube, just being a cube, will probably look fine and look like it's printed okay. I need to test like these kind of things. Yes, I can fix the part that printed badly. That's not an issue. But what I want to do is dial in my printer so that it doesn't do that in future. Sam check messenger. Okay, let's have a look. Oh, it's because it's 3D benchy, not just benchy. Okay. Let's have a look at this one. Yeah, maybe an overhang file would be good. Is it downloading or what? Yeah, downloading. Okay, cool. Okay, well that doesn't work. Quad feed, that for some reason doesn't work. Don't know why. I think maybe there's an incorrect number in your one quad feed. Perhaps. Calibration pyramid, that sounds good. So that was the thing that failed, wasn't it? That looks good. Overhang test. That one doesn't work. Sorry, Matt K, that one doesn't work. Oh no, was it 666? That one doesn't work. Alright, let's have a look at some of these then. So this is a temperature test. Okay, that would be, oh no, so not temperature, sorry, this is, yeah, overhangs, right. So let's see how that looks. So I've got my 6mm nozzle in there at the moment. I need to change this back to 6mm. Profile. I have to build a new profile on this, so 0.36. I should be able to print with 0.36 on this. Shouldn't be an issue. Line width, 0.6. Wall thickness, 3 walls, 1.8. Top bottom thickness, print temperature, let's go up to 225. Print speed 60. Start off at 60. Let's see how it goes on 60. If it sucks, we'll try it at slower. But it should be able to do 60 just fine, given that it can do 120 millimeters a second on my 0.4mm nozzle, and that's just fine. Traction distance, that's all fine. Okay, look good. Shouldn't really need much of a brim on this. Yeah, I'm going to up the infill a little bit. I'm going to go up to 30% infill, just because that won't have much to kind of tack onto. So. Yeah, that's going to be hard for it to do that, but let's see how it does. I'll save that. See how it does. Okay, let's plug it in, see what happens. I realise this is not a very interesting stream. Apologies guys, but I'm feeling quite tired today. Just want to kind of get this 3D printer stuff dialed in as well. So. Fucking hell. Come on. Right, stay. Thank you. Okay. Choose away. Preheat and see how it goes. Right, let's have a look at this little thing. Oh, this box sounds a bit rattly. What's going on in this one? Okay, here we have an Edge EDB 1000.1, cheap little thing. Says amp keeps blowing all three 35 amp fuses when connected to power without having any load on. That's going to be a power supply section failure, my friend, and possibly outputs as well, depending on what's caused the power supply to fail. Seems like a fairly new amplifier, this one. So we're expecting to see dead power supply FETs at least. So let's have a quick look. Power supply MOSFETs in this amp are going to be over this side, near to the transformer. So yeah, looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 power supply FETs, 2 rectifiers here, and then 4 output FETs over this side with the inductor here. Drive circuit is this 2092. Yep, 2092 driver. Really basic circuit this. Holy bananas. Extremely basic. But the 2092 is a good Class D drive, I see, so. Huh. Okay, that's interesting. Don't seem to have any dead power supply FETs. What about outputs? Ah, we have dead outputs. So his fuse was blowing when he was asking the amplifier to turn on. All of the outputs are dead. Okay. Is that even worth fixing? Yeah, some money is better than no money for me at the moment, so... You know what, these parts don't even look genuine. These look like fake AF 4115s. These are supposed to be IRFB 4115s. But I'll show you the markings in a minute. They do not look legit in the slightest. They could be, but they really don't look it. Sam, are you ever coming to the States for anything? I don't think so. Not that I'm aware of, no. Came to the States a few years ago to Digital Design's headquarters. It was good fun. Oklahoma, yep. Oklahoma, also went down to Dallas as well. Went down for Knowledge Fest in Dallas. So if you want H6 FETs, you can replace them with kind of whatever you like that is a similar specification to the IRF 1404. So have a look at the IRF 1404 datasheet and either use those if you can get them or replace them with something similar. Thanks, Stephen. Appreciate that. That's cool. Okay, here we go. Print is off. Wait for the bed to come back up a bit. Bed's nice and level as well. I get good adhesion to the print bed. Took a long time to prime actually. There was a fair gap where there wasn't any but that might be normal. Okay, here we go. So it looks pretty nice so far. Yeah, that first layer looks good. Not really got any gaps in it or anything. Let's have a look, see if it's got any gaps in this this first layer it's putting down here, this this bottom piece. Yeah, so the first bottom piece doesn't seem to, like, there's kind of gaps in between the lines a little bit. I want it to smush out and like completely fill. So I don't know if, I'm not sure how well you can see, but there's kind of gaps in between the lines. And I want that to just be like completely smushed up against each other. It doesn't look bad. It looks kind of pretty good, but not super amazing. Yeah, I do plan on doing a time lapse of the boom or bust enclosures. Just need to get a camera set up, and the camera needs to be plugged into the mains because obviously a battery powered camera would definitely run out of battery with the amount of time that some of the prints take. Just need to get something sorted out, hooked up for that. Extruder steps per millimeter. That's an interesting one. Okay, I have looked into that before. Is there a calibration test print I can use for that? Or do I need... Oh, I think I need to extrude a certain amount of filament and then measure it, don't I? Or something like that. Like, get it primed, tell it to extrude, like, I don't know, 50 millimeters, and then measure it. An old phone that does time-lapse. Yeah, that'd be a pretty cool idea, actually. I do have an old phone. I've got an old HTC 10. Problem is, the battery on it is so dead. The battery is so dead. It's kind of like it's no longer there. So even with the phone on charge, in a high current charger, USB charge plug, if you try and do too much with the phone, it just turns off because the voltage drops below its minimum threshold, even with it plugged in. Because the battery is just like so dead. Tell it to extrude 200, it will make getting it dead on easier. Okay, not a bad shout. Open it up and put a power supply on the pins. That would be good, but the HTC 10s are notoriously very hard to get open. I took it to a few repair shops to see if they could put a new battery in it, and they said, yep, they can put a new battery in it, but I also have to pay for a new screen, because 9 times out of 10 they break the screen when they try and take it apart. So That's why I didn't ever replace the battery on it. I would love to replace the battery on it. It's still, the phone's still fine. Like I use it in the kitchen for music because it has a headphone jack. So I have it connected to an old Technics amp and some speakers in the kitchen, listen to some tunes. But yeah, it turns itself off. It's making some very funny sounds, the 3D printer. I think it's because this is such a small part. I don't usually print such small parts. Does anyone else quite like the sounds that the 3D printers make? Like it kind of sounds cool to me. Yeah, have a listen. 3D print ASMR stream. That's the tiny infill. Cute. Better than the old modem connect sound. Yeah, I used to like that one as well. I used to quite like the sound of floppy disk drives as well. It's all kind of stepper motor stuff, isn't it? Really. I like stepper motor sounds. I think they sound pretty cool. I like regular printers as well, like the old printers that were quite noisy. Does it have a smell? Like the 3D printer? Yeah, there is a bit of a smell, bit of a PLA kind of smell. It's not meant to be good for you, not meant to be that good for you. So it's probably not the best idea having it printing while I'm sitting here working. But yeah, it is what it is. I have a generic amp board similar to your base phase DB3s. On the side of the rail caps are two spots where big resistors would be outlined in white but not installed. Those are probably pull down resistors. So all they do is they just pull the rails to ground. So when you turn the amplifier off, the rail voltage just gradually sinks to ground, making the amplifier safe to work on after about 5 minutes of after it's been turned off. They don't do anything for the circuit in regards to reliability or operation or anything like that. They're just like a user safety measure, so they don't need to be installed. Right, what's the health status of this 2092 drive IC then? Now, 2092s aren't as easy to quickly test and diagnose as like the 21844S, because the 2092 won't give you any pulses without FETs fitted. So I'm just going to go ahead and see whether we've got somewhat sensible multimeter readings across the gate path and source of the pads where the MOSFETs would go. That might tell us a little bit about the health status of the 2092, but not everything, but it might tell us a little bit. So, this way round, 16, 18. Try to get that to focus a bit better on the multimeter. I don't know why this camera wants to focus just on the background, never on the foreground. There we go. Yeah, it's not anything crazy that I wouldn't expect to see on these two here. If you see the exact same number when you flip the probes, that can be a sign that there's an issue. Like, so if you got the probes this way round, if I flip them round and I also read a 732 or something like that, that could be a cause for concern. So everything's checking out okay at the moment. That doesn't tell us for sure whether the drive circuit's okay, but it's a relatively good pointer that it's not completely mutilated inside. So this amp was using 4115s from the factory. They look a little bit suspect. The font doesn't quite look right, firstly. Secondly, this dot in the middle here usually is stamped with some kind of marker, some kind of stamp print, like a letter or number inside that hole, which is not there. Also, on 4115s, we usually have indents here on the sides, which aren't present. Although, other things about them which suggest they might not be fakes, the epoxy looks pretty good here. Yeah, there's just something about the font, and it looks like it's a little bit offset, like it's not dead straight. That just kind of gets my whiskers twitching a little bit about these original ones. And now, unfortunately, what the best thing to do would be to drop these in the transistor tester to see what they read, especially the gate capacitance. If the gate capacitance value is way off, we know that they're fakes. But because these are all dead, I don't think we can do that. These are all dead shorted. What we could do, actually, one really cool thing. Oh wait, here we go. I think this one might have survived. Ah, yeah, one of them. I think one of them survived. Ooh, hang on. I'm just looking at the print. Oh no, yeah, it looks alright. It's actually looking great so far, guys, the print. I don't know why it's looking so good compared to... Anyway. Yeah, I'm going to drop this in the tester, because I think this one survived, and we can get an idea as to what its specs are based on the gate capacitance value. Well, maybe not. Okay, now I think this FET is actually dead, but it's just not dead short. Oh wait, there we go. Okay, so gate capacitance is pretty high, up at 6.5 nanofarads, so maybe these are actually legit. Maybe I might have just been a bit being a bit too critical. If they were fakes, if they were like rebranded 640Ns, then the gate capacitance would be like way lower, like 1 or 2. But I think 6 is about right for 4115s. We can have a look because we do have some fresh 4115s that we can compare against. Just got to find them in my drawers here. Let's have a look. I should really get around to labeling these. I haven't labeled these yet, and it makes life take a lot longer when I'm trying to find parts, but I will get around to it at some point. I usually know roughly where the parts are that I need. They're 1404s, power supply. There we go. It was the last drawer that I checked. That's always what happens. Right. White Dymo label printer. I have one. I just haven't used it yet. I've used it for other things, just not that. So a genuine, legit 4115 has a gate capacitance of 7.1. Yeah, it's close enough to what the ones that were original in here, so I think they probably were original, they just looked a bit weird. Although what's interesting is these ones that I have bought that are genuine, because they're from Farnell, they also don't have the letter stamping in the middle circle here, which is interesting. I thought they all had that. But what we have on this one is we do actually have the indents on the top here of the FET. Whereas on these ones, do they have it? Oh, I think these ones do have, yeah, these do have it as well. It was just covered up by thermal paste. Okay. So what I'm going to do is I'm going to actually drop these in and see if the drive circuit's okay first. No, I'll just put one per bank to start with. I'll just drop 2 in first and see if the drive circuit's alright and start switching. So I'm just dropping one MOSFET per bank to start with to see whether the 2092 driver is okay. And if it is, we'll put the other two FETs in. Tell us about the Blue Tack. So basically, Blue Tack sell lots of different variants of Blue Tack, and one of them is pink, and they call it Pink Tack. And just so happen to have some Pink Tack laying around, so that's what I used. Blue Tack is usually blue. It's not usually pink, but it's just what we had laying around here, so that's what I used. Alright, let's plug some wires in, power it up, and see whether the drive circuit is okay. Seems to be doing quite a nice job so far, but some possible artifacts on the underside of the overhang, which I'll have a look at. I'll show you guys in a bit. Do you know anything about the Audio Apex Cab 22? I don't, unfortunately. Don't get those in the UK. I just got one at a contest. Nice. Looks like an amp from around 2013. Pretty sure Type 4 board. Anything you should watch out on them? Yeah, they're pretty generic. Common things to fail on those, the output FETs just randomly die. The issue on those that I think is that because the drive circuit is isolated from the output buffers by optocouplers, I don't think that enough I don't think the optocouplers can either switch fast enough or enough signal gets through. If you probe the drive waves of those style of amplifiers, if you probe the low side gates drive wave, it always looks absolutely horrendous. It looks really, really weak and really curvy, often with a great big spike when the MOSFET turns on. So they seem to have really, really weak drive compared to most other amplifiers, and I think that's one of the reasons that they struggle with randomly dead output MOSFETs so often. The most common thing you see on those amplifiers is the output FETs will just randomly fail for like no reason, even at idle, even without a load on them. Okay, let's see whether the drive circuit is dead or not. So we're going to find the low side first by giving it a couple of pulses of the remote. Oh, it's probably not got fuses in it, has it? Because the guy said that it blew all the fuses all the time. So let's just quickly bridge over the fuses for a second. We'll put some replacement fuses in once we fixed it. Okay, so that's our high side, hopefully. And that's our low side. Okay, cool. It's switching just fine. So yeah, the 2092 driver survived, so it just needs 4 new output FETs. Do you want to see it? Let's see how it's going. Okay, I think it's starting to fail now. I just saw that that piece just completely drop off into the ether. Yeah, it's starting to drop off down the edges now. Yeah, it's failing now. So that's about the limit there, whatever that is. So yeah, I can't go any more than that with the current print settings. I think if you notice as well, I think it could be a cooling issue, because the cooling fan is this side, but the overhang that needs to dry really quickly, that needs to set really quickly, is over this side. So the air isn't actually able to cool that bit of filament quick enough while it comes out the hot end. I might stop it there because I can see that it is starting to droop down. So yeah, I might call it quits there. Good job, little buddy. Maybe should I keep it going just to see how it does? Like, it's definitely drooping badly now. But I can keep it going just to see what the end result looks like. Yeah, I've seen the fan shrouds on Thingiverse, but I got so confused with which one I should print. There's like 100 different versions and like updates, and some of the updates don't print as well as the older ones, and I was just like, I got a bit overwhelmed with the amount of options that there were, and also I looked at the file and I couldn't figure out how it went together, so I haven't printed a shroud yet. Yeah, it's failing now. I might stop it now. Okay, stop. You can stop now. You're low enough. Does anyone else do that? I tap the Z down button like a bunch of times like this, and end up moving the plate down way too much. Can anyone else see the can anyone else see the nice big stick here? That's hilarious. Okay. Yeah, that's very well stuck. I need to get a knife under that. Ooh, you bendy. Right. Yeah, I should have waited for the plate to cool down properly before I took it off because it's a bit bendy. But yeah, this is how we're looking. So not great resolution on the numbers, obviously being a 0.6 as well. It's quite droopy actually. Yeah, look, it's almost like I've not quite got enough cooling. I would say that my temperature's a bit hot perhaps. So let's have a look at the detail on the numbers here. So I don't know, I'd be tempted to say that the temp's a bit hot. And then obviously it doesn't look great on the back, to be honest. Like, it looks like I can only go to about 40 degrees, 45 at a push before it starts kind of looking quite bad. So, okay, I might print another one, but I might change the temperature a little bit, maybe a touch lower. Not sure really. This was at 220, so my filament wants between 215 and 230. This is my filament. If I get one that's open, tells you on it. Oh, between 200 and 230, sorry. So this was at 220 at the moment. Try more fan speed. Fan's already at 100%, so I think I just need more cooling. Is your printer doing a smoothing pass between layers? No, I don't think so. What I might do is I might actually try printing it the other way around, because that way the fan is getting it better, but that's changing too many variables. So I should try changing a variable, changing a setting, and seeing if that makes it any better. So that was currently with all of these settings. Okay, here. So let's have a look. What could I change to improve it? So if we look at the part, we've got so the back side looks pretty bad. Anything above 40 isn't really usable. Below 40 looks great. Like, you know, the flat stuff looks fine. The details aren't that great. Like on the 30 here, for example, not that great. But it is a 0.6 nozzle. It's not super high detail.
I think the fan was already at 100%. Yeah, so the fan's already at 100%. So I think to improve this, better cooling would definitely help. Let's see if we can find. Can anybody send me a Thingiverse link then to the proper fan shroud for the Ender 5 Plus? Or actually, it's the same hot end on the 3 and the 5, I think, isn't it? Try it slower. Try printing sideways. The back actually looks like too much cooling. So I'd say the layers are not adhering because they're drooping. That's the issue. So as it's printing, I can see like the print drooping down. So you can see here how it starts off. It starts off printing okay at the top here, and then it sort of droops down. So that's why they're not adhering because they're just like sagging down below where they should be. People saying print sideways and flip it over. That's not the point. This is specifically a test to test your overhangs. If I print it on its side, that's not testing my overhangs. That's completely pointless. It defeats the object. You're supposed to print it like this to see how well your printer can print overhangs. I'll try a bit slower then. Shall I try a bit slower? Let's go to, I'll knock the temperature down a bit to 215. Okay, and I'll print instead at 30. Just to see if that looks any better. Yeah, let's try that. Should I spin it round just to see whether it makes a difference printing it that way with the fan? But that's kind of cheating, isn't it? I should keep it the same. So yeah, I'm even slower now then at 30. See how it does at 30.
Could try to enable bridge settings, but that'll just slow it down on overhangs. Oh, that's kind of interesting, because it'll still print the rest of it quick, but it'll slow it down on overhangs. Yeah, maybe I can check out those settings. That'd be great. Attic, or if you tilted the whole printer as the angle increases. Well, interestingly, they are now making printers that rotate the hot end for that exact reason. So rather than rotating the whole printer, they rotate the hot end. So the hot end has more degrees of movement. I think it's this six depth of field, is it? It's currently got 1, 2, 3 axis movement. So with the hot end rotating as well, it adds another 2, 3. I'm not sure what it is, but anyway, it looks really cool. YouTube it. I can't remember what exactly it's called. But they're also doing it now where the z-axis, the z-axis moves as well while it's kind of printing different parts. There's some cool stuff going on with slicers at the moment that might make its way into Cura at some point over the next year or so, that might improve stuff like this or other difficult to print things. I'd love to get a dual extruder 3D printer at some point in the future, so I can print with the supports that just disappear in the water. That'd be great. That'd be super useful.
there's a purge bit there. I just want to try and get rid of. There's a bit of. There we go. Oh, it's printing a different way round this time for some reason. It's now for some reason it is actually printing a different way round. Interesting. That's annoying. I might stop that because that's going to completely ruin our experiment. That's going to completely ruin our experiment because that is too many variables changed. Why has it started doing that? I didn't import it in any different way to how I did before. Right. Oh, problem is I don't know which way round that was because it's just a rectangle, isn't it? Overhang. Okay, I'm going to guess that I need to spin it this way. Right, let's try that again. Right, let's check the gate resistors for those other two. So these two are in parallel. Yep, looks good. These two are in parallel, looks good. 4.7 ohm gates. Cool, cool. Okay, it's powered up. Make sure that it's good with 4 FETs in it as well. Cool, yep, there we go. Got switching on both of the low side FETs. So we have a look at the gain position. So this amplifier was sent in and I haven't touched any of the dials on the side yet. This could be an indication as to why it might have failed. So have a quick look at the settings. How were they set? This is a very, very cheap amplifier. So the gain is... Okay, the gain's up on about a third. I was expecting that to be near full. Phase, bass boost, subsonic, low pass. Yeah, I mean that's actually fine. I was expecting them to be all over the place.
There's a few amps I've done recently that have come in that have had all of the settings on maximum. So what was the one variable that I changed this time? I think I just made it slower, didn't I? I reduced the print speed, and I think that was it. Oh, and 215, yeah. So reduce the temperature and reduce the print speed a bit, yeah. Yeah, hopefully that's not too many variables to change at once. I don't think the temperature's going to have a huge impact on that overhang stuff, but I want to see whether it changes the detail on the letters, on the numbers a little bit, to make them a bit nicer. This was purchased in September. So it's either been running for a while just fine, or they haven't used it and they've just gone to use it now and then it's failed. Right, what now? What now? Oh, I need to look at these things. There's a guy that's been really on at me about looking at these things. These are not an amplifier. Apparently they are power supplies for industrial chip fryers or something. He sent in an Alpine amplifier, which didn't have anything wrong with it, but he also sent these things. He was like, can you have a look at these as well for me? I said, oh, I'll have a quick look, but it's not really something that I generally work on. So these are mains power supplies for deep fat fryers. He wants me to look at them as soon as possible because I guess it's impacting his business not having the chip fryers working. So we've got a big transformer. Hey yo, this looks fucked. We've got a big transformer, looks like got a fair bit of soot from maybe something that burned there. If we look at the back of the PCB, we've got massively blown out traces. This trace is missing, that trace is missing, that one's missing. Whew. Ah, that looks like an inrush suppressor. This part has blown its load right open. Holy crap. Okay, let's get that part out of there and see what it is. That's either a capacitor or an inrush current suppressor. Possibly the rectifier failed, yeah, maybe. We shall have a look. Hamilton, I've been streaming for over 3 hours already. So this is the part that has visibly failed. Does it have any markings left on it for us? Don't think so. No markings left on it. It's either an inrush current suppressor or it's a capacitor of some kind. I think it might be an inrush current suppressor. Darktron, where can I donate to help support a tiny portion on Boom or Bust? That's very kind of you, man. Send an email to nsvaudio@gmail.com. nsvaudio@gmail.com. Just popped it in the chat there. Yeah, drop me a line on there and I'll give you a shout. I'll let you know. Right, let's check the rectifier. Let's checktify the rectifier. So those two are probably AC input because there we have a short, a connection. And these are probably the output. So, okay, not getting any short across the whole rectifier itself. So if we take a look on the bottom of the board here, we have badly blown traces. So the traces are badly blown between the live input here. So the live coming in, the traces completely vanished from live to the inrush current suppressor. We also have, I think is this the fuse here. So it goes to the fuse here, other side of the fuse. We've also got the trace completely blown on the neutral. So yeah, it looks like the inrush current suppressor failed, presented a direct short between live and neutral, completely taking out these traces here. See that? So the burnt area is live through the inrush current suppressor to neutral. So that doesn't look good. Now, in terms of repairing this, we might be able to get away with just replacing the inrush current suppressor, rebuilding the traces, and it might be good to go. I want to take a look at what's going on the board here, though, whether this is just soot or dust. Yeah, I think it's just dust. I think the transformer itself is okay. I think it just got covered in black soot from those traces completely exploding. Let's have a look at the fuses. They're okay. So the actual fuse is new. The circuit is okay. Ah, you know what? You see, there's another one of these blue things here. I wonder whether that's the same as the part that failed. Is it the same kind of size? It's a bit thinner. No, it's not the same part. Oh no, guys! It's printing the wrong way round again. It's printing the opposite way. You know, I had to guess. Oh, that's really annoying. It's printing the opposite way round. I'm going to let it print that way round. This way is getting the best cooling. It's getting the best cooling this way round. So it's now printing 180 degrees flipped to what it was before. So I'd be really interested to see whether it being that way round makes a difference with the cooling fan being very blowing at the backside now. But yeah, unfortunately, that variable ended up being changed, annoyingly. Let's get the other one of these power supplies out, because I've got two of them. So hopefully the inrush current suppressor is in better condition on the other one, so we can see what model it is exactly, or what the markings are on it. Okay, here's the other one. So yeah, same thing happened on this one by the looks of it. This blue part here, which we're suspecting is inrush current suppressor, has blown its guts. Is that the right size to go on there? Almost. My socket set's downstairs, so I'm just going to do this for the time being. Yeah, so it's the exact same failure on this one. Those traces that lead to the inrush current suppressor have completely blown open. Between these two. Yeah, exactly the same issue. Interesting. If I remove this part, let's see if there's any markings on it that are left that we can read. I don't know. I've seen inrush current suppressors go bad when people are turning devices on and off very quickly from the mains, just like absolutely knocking the inrush current suppressor continuously. So this one's in a bit better condition, but it's still lost all its markings. No idea what that is, unfortunately. We could replace it with, you know, we could try and guess what it is. Just replace it with an inrush current suppressor. I don't think the transformer wines are shorted. We can check. I can measure them. Can measure the inductance of the wines here. See if any of them are shorted. I suspect they'll be alright though. So if we have a look at the transformer wines, we've got two here. So look, what have we got? We've got mains coming in. So it looks like we've got high current on this side, high voltage on this side. So it depends if this is stepping up or stepping down. I assume it's stepping down. So it looks like we have mains power coming in here to this side, and then high current coming out this side. So let's grab my tester and have a read of the wines, shall we? Get some wires on that. Yeah, so the next episode isn't Battle of the Sixth Orders. That'll be coming some point soon. I've got a few boxes that I can't decide what one to print next. At the moment, what's being printed is actually just a test print to try and dial in my 6.6mm nozzle a bit better. Okay, so we're measuring the inductance of the primary here. You can't really see that on the screen. Put something behind it so you can see it. So the primary is currently reading at 18.4 ohms with 19.9, what was that, microhenries. And it comes back up again. 19.6, oh no, sorry, 19.6 henries. Wow, okay. Obviously, yep, no worries. So 19.6 henries on the primary, about 18 ohms. And let's have a look at the secondary. I can get in there. So secondary is 0.4 ohms and 159 microhenries. Okay, so let's go over to our other one just to see whether they're the same, roughly the same or not. (169 microhenries). This one's quite a bit, well, it's reading lower impedance, 0.1 ohm. (169 microhenries). Could just be me not making a good connection though on the test leads here. Oh, 0.5, yeah. Yeah, they're pretty much the same. Last but not least, let's check the primary on this one. Anything? Do we have continuity? Yep. Must just be not. I must be not touching it enough. Okay, 9. That is 23 Henrys. Yeah, so the transformer is reading fine. The transformers are fine. I think it's just the inrush current suppressors failed. That's what I think it is. So, have to order some more of these. No idea what they would be. Anyone got any ideas? That's what they look like. Completely toasted. They are thermistors. Are you sure? Okay. Looks like this one has an A written on it at the start. We've got some markings left over. Let me show you what markings there are left over. Let's turn this camera on. Okay. So looks like this one says 275. I think that's a 2. 10 275 and then unreadable. On that one. The other one, nothing really very readable on there. There's an 06 at the bottom there. Right, how's this print coming along? Shall we have a look? Okay, that looks a bit better. I don't know if that's in part due to the cooling, the better cooling that it's got. Now it's printing that way around, or the fact that I slowed the print down. But it looks way better. That's the unfortunate thing about having it spun around like that. I wanted to know whether it was just the print speed or whether it's the fact that the cooling is better on that side. Kyrie suggests MZ75. Does it look like a Z? Could it be a Z instead of a 2? No, it's too rounded to be a Z. I can see the rounded part of the possibly a 2. Yeah, it's definitely a 2, not a Z. Okay then, guys. So I just want to have a quick look at. So I've printed my next box for Boom or Bust already, anyway. But I want to have a look at the next one. So we've got. Is it this one? Yeah. Here we go. I want to print this one next. I think this will be kind of cool. The only thing I'm slightly worried about is this part here. So if I slice it with the same settings we just used to print this overhang that I'm doing. I'm a little bit worried about this tube here. Like, that's quite a big overhang, isn't it? And I can't really add any, what do you call it, supports for that, because I won't be able to get them out. Also, it doesn't really look very pretty down here either, does it? Look at that. That's going to look really janky, that is. I'm thinking whether I should just go back to my 0.4mm nozzle, you know. Yeah. Gyroid 215 65. I'm just checking the time difference. This is with the 0.4mm nozzle now, with the kind of average settings that I would otherwise use. So with the 0.4 nozzle, it's only an extra hour longer because I can print faster. And there's a lot more detail there, as you can see. So I might just go back to the 0.4mm, you know, guys. If I have to print this much slower with the 0.6, I don't feel like there's much point. I don't think it's a thermistor. I think it's an inrush current suppressor, honestly. The number above the 275 is a 10. 10 by the looks of it. Yeah, 10 above the 275. I would say that's 275 volts, wouldn't you? Wouldn't you say the 275 is a voltage rating? And the 10 is possibly like specification of the part. It's a varistor. Yeah, Kyrie 10K 275 volt thermistor. That might be what it looks like. I will do a bit of research and Yeah, probably grab those. If it's feeding the heating element of a fryer, it could be inrush current limiting since the element will be a dead short or turn on. Yeah, I think that's literally what it is. So whatever I replace it with, I'm gonna have to go up on the current rating or the power rating of it, make it chunky. Okay, we're starting to fail now a bit. Yeah, yeah, we're pretty much full failed on this now. So let's stop that print. Stop. Settings, move. Okay, wait for that to cool down a minute. And I'll take it off and have a look and inspect it. I think 275 volt is just for UK voltage, because obviously we're in the UK, so we have 240. So they wouldn't use a part that was rated for 240 because that's right on its limit. So 275 is kind of the standard rating for mains parts in like power supplies and stuff, because it's a bit of headroom above the 240 that we give it. Okay, so how are we looking on this one? This one, compared to the other one, so it's sort of similar-ish. It is better. It is better, but it's kind of similar-ish. It is a bit better though. Let's have a better look with this camera. So this one's the. This camera just doesn't want to focus on what I actually want to focus on. So this one is the first one that we printed. This one's the second one that we printed. Much slower. So yeah, it does look better. It looks like that the second one with the slower print and the cooling on the correct side, looks like I can kind of quite easily go up to about 50 degrees. The numbering still looks pretty much as bad as each other. It looks a little better on the slower one, but not like wildly better. Yo, Mickey, thanks so much for the 20 bucks, man. Welcome to the stream. Excellent. Unfortunately, the stream is kind of drawing to a close soon, I'm afraid. Sorry, buddy. Thank you so much for the 20, though, man. That's quite a lot of coins to give someone over the internet. Thank you very much, my man. So, yeah, in terms of the back quality, it's definitely a bit better doing it slower. But it could just be the fact that we were cooling on the correct side now. You know what I might do? I might print one more, okay, but I'm going to bang up the print speed like a lot. I'm going to absolutely crank the print speed, and just to see what it does. Check the bend resistance. Yeah, it feels about the same. So the pyramid project, I've already printed it, so I'm just going to have to seal it off and use it because it was a lot of filament. I don't want to waste any more filament on it. So I'm going to print it one more time, but this time crank up the print speed. I can crank up the print speed on the printer itself, but also I can do it in Cura. I don't know what would be better. Would it be better to crank up the print speed? Yeah, it'd be better to do it in Cura because then it will keep the other things the same, won't it? So, okay, if I Control Z. Okay, there we go. This part here. Let's bring it back to good slow. Discard changes. 0.6mm nozzle. Yeah, this is all the same. I'm going to crank the temperature back up a little bit. If I'm going really fast, I might as well crank the temperature back up a little bit. Let's go 220. Speed, let's go YOLO. Let's YOLO it at 110. Let's just see what happens. Would a resin printer work better? A resin printer is very brittle. Resin is very brittle, so I possibly it would be okay. But resin printers don't. You can't print very big, so it wouldn't really work for this project because we need to print quite large. Maybe after this I'll print one of these in a 0.4 as well with a 0.4 nozzle, just to see how much better it looks. If it looks like a million times better, I might just stick with a 0.4. I was under the impression that you could pretty much print with a 0.6 with modern slicers and it would look as good as with a 0.4 that used to. So yeah, interesting one. Right guys, I'm going to shoot off now. We repaired 2 amplifiers today. Yay, go us. 2 amps down and messing around with the 3D printing stuff. I'm going to keep at it. I'm going to seal off this pyramid box. The nail varnish doesn't seem to be doing a great job. I might have to go up to something a bit more watertight. But yeah, let's try dropping another layer on. I'll drop another layer on and see what it does. And then I'm going to try and film this, but obviously I can only film this once it's watertight. So I was going to try and film it this evening, this episode, but if it's not watertight, then unfortunately I won't be able to. Very annoying. Where's the nail varnish gone? Where is my nail varnish? Oh, here it is. Hysteria's Beast, yo, thanks for the 20. Here's some funds towards new leads from repair techs in Texas. Man, thank you so much, buddy. That's awesome of you. Very, very kind of you, buddy. And a 26 from Draxon for the filament. Oh my god, you guys Holy shit, thank you so much, guys. I really, really appreciate it. It makes me feel a lot better about possibly wasting a bunch of filament on this one. So thank you so much, guys. I really, really appreciate you helping me out here. Super, super cool. Thank you very much, guys. Not needed at all. Not needed in any way, but thank you so much. I guess the overhangs on this one might have been a bit much for me to expect the printer to be able to do. Like it is very overhangy, isn't it? This shape here. So yeah, hopefully I can get this watertight by this evening, and then I will film it, and it will be edited tomorrow for going up on Friday. I'm trying to do these weekly, so yeah, trying to get them up on Friday, every Friday if I can, because Friday seems like a good time to release the videos. It's when everyone's kind of got home from work, or they're chilling out on Friday, watch some Boom or Bust. You know, it's good vibe, innit? Good vibes, good vibes. Yeah, as I'm holding it up to my massively bright lights here in the workshop, it does show through where it's all very like very not very tightly printed, if that makes sense. So it shows up all the holes pretty much when you put it on the light, so you can see whereabouts they are. You can see how thinly it's printed, this top piece. The rest of it's fine, but this top piece just did not print very well at all. You can use adaptive layer height in Cura. Don't think I've seen that setting yet. Shit, I can't look whereabouts is that setting. Let's have a look. Let's go to Cura. Let's bring in my part that I want to print, which is this one. So, okay, let's have a look. Where would that be? Experimental, perhaps? Let's have a look. Adaptive layers, maybe? Adaptive layers computes the layer height depending on the shape of the model. Let's try that. Maximum variation, step size. Okay, let's give it. Use adaptive layers. Adaptive layers of maximum variation with a 0.04 millimeter difference. Now let's go for a whole. If I'm doing 0.36, let's go for a 0. Let's go for a whole 0.1 millimeter variance. Let's give it quite a lot of variance that it can switch between. Let's have a look at this one. So has it done that? It looks like it might have actually done that. These bits look a bit more detailed than they did before, I think. But I'm not sure how to tell whether it's doing it. I might be asking a bit too much of it on this bit here. Yeah, you see this bit here, I might be asking a bit too much of it here. We'll see though, but it might sag down a fair bit on this bit. Like that red one, for example, that's just kind of floating in midair. It's just going to be attached to the one next to it a little bit. Use tree supports and select touch build plate to solve that small area. Alright, let's have a quick look at that. So we'll go to supports. Touching build plate. Support structure. Support density. That's probably enough settings. I read something about using really low density tree supports and that being quite good, easy to take off. So yeah, looks like it puts supports up the middle here. Oh, sorry, I hadn't changed it to tree. Never mind. Branch angle, tree support branch, distance, touching build plate, density 5%. Okay, let's try that. Okay, that looks cool. Yeah, that might be good. Although, how easy is that going to be to get out the port? So it's going to snap off, but then it might be too big to get out the port. And will those branches even print? I guess they probably would do. Well, half of that's not going to bloody print, is it? Look at this top mesh. Look at this purple top mesh. It just freaking prints bits of it in midair. That's definitely not going to work. It's just gonna like put random bits of stuff in the middle of nowhere. What about if I increase this? No, it's still the same. It doesn't seem to be printing this overhang test any quicker than it was before. I just banged the speed up on the actual printer itself to 180%. Let's go up to 200. Can you hear the difference in sound as I increase the print speed? So this is currently at 200%. Let's YOLO it. Let's go 250%. I just want to see what it looks like when it's going too fast. It's even faster now. Yeah, this is a bit weird. Not sure about that. What if I change this to 60? Does that change it at all? Nah. 30? Nah, that's no good, is it? Needs to be tree. I'll have a play with it, guys. I'll have a play with it. Yeah, I can put support blockers in. I've messed around with that in the past as well. Cool. Yeah, even at 250% speed on the printer, which is, so I currently set this one to print at 100 and something, but because it's doing small walls, I don't think it was actually printing as fast as 110, 120. I can't really tell how quickly it's printing now based on the sound of it, but I've got it set to 250% speed on the printer, and it's like, it's printing fine. The extruder's not skipping. I'll let it go for another couple of minutes and I'll take it out and see what it looks like. Right, should we see if that's made it any more watertight? I'll go and fill it with water again, see if I can see where it's spilling from. No, sadly it's still incredibly leaky. Where's it leaking from though? Down the sides, all lower down. Yeah, I think I'm going to have to completely cake it in some kind of sealant to just like absolutely cake the whole thing in some kind of sealant. It'll look like rubbish, or maybe paint it. Maybe painting it would be a good solution, like with some like thick kind of wall paint, you know, interior paint, something like that, or exterior paint might be the solution. Yeah, some kind of paint. I think I might paint it because otherwise it will look like ass. Problem is, if I paint it, then I can't film it tonight unless the paint dries relatively quickly. I need to print it. I need to film it tonight, ideally. Worst case, tomorrow. Yeah, if I paint it, I can paint it inside and outside. That should help a bit, shouldn't it? Yeah. Right, that's the super fast print done. So in regards to how that looks, so with the super fast print, it looks like I don't have good wall adhesion. So this is the faster print, and you see how that's not actually stuck very well, is it? Ah. So that could be under extrusion because it was too fast. So that's something to bear in mind. But I mean the overhang looks fine in regards to it being printed really, really fast. So this is the very slow print. On the very, very slow print is on the right, and the very fast print is on the left. Like, they don't look that different, really. Like, a little bit, but barely. But yes, wall adhesion not good on the faster print. The wall adhesion's better on the slower print, although it's still not great. Like, I can still pull it away. Look, this is on the slowest print, okay? The slowest print speed, like super, super slow. I can still quite easily pull that wall away. I shouldn't be able to do that. Why is it doing that? This is the first one that I printed. This was at medium print speeds, like 65. More heat on the bed. I'm already at 65C. I don't really want to go much hotter. More nozzle heat. So I'm at 220 degrees Celsius. The limit for this PLA is 230. It's almost like it needs to squish out more. Do you know what I mean? Like, it's printing fine, but it's not pushing it into the wall next to it enough. So it's almost like it needs to squish more material out and squish it into the wall, or more overlap. It needs to overlap more, perhaps. Something like that. Have you printed a lower temp? Have you printed a temp tower? Yes, printed a temp tower. If I go below like 215, then none of the walls adhere very well at all. So maybe I need to go to 230. Yes, the Z offset is set correctly, bed leveled nicely. Yeah, the leveling is good. It's just I think it's just like a kind of temperature overlap kind of issue or something. Not sure really. This PLA does definitely seem to want to be printed quite hot though, so. Anyway, guys, it's time for me to go make some dinner. Don't you need more heat with a bigger nozzle? Yeah, I have increased the heat. I used to print 215 with the 0.4, and that was great. Didn't get any issues. I'll tell you what, the 0.4 nozzle, absolutely fine. No issues with the walls coming away. Beautiful prints. Extruder E-steps could be the thing I need to do. Yeah, that could be the thing. Extruder E-steps. That's the thing that I'm going to try next. So yeah, I'll try the extruder steps, and then I'll try a higher heat. But with the 0.4 nozzle, it was printing beautifully. So if I can't figure it out, I might just go back to the 0.4. Anyway, have a great evening, guys. Catch you later in Boom or Bust, hopefully.